The development of a Llama Stack and AgentOps integration is entering its final stages. For those unfamiliar with the Llama ecosystem, Llama Stack is an agent framework authored by Meta, and it pairs nicely with another tool called Ollama. Ollama is a tool that allows you to run LLMs locally on your own machine, aka your laptop or desktop, or whatever home-built device you want to run these models on. Yes, while Llama ecosystem models tend not to be as large as, say, frontier models like GPT-4o or Claude 3.5 Sonnet, you'll be surprised to hear that for many use cases, they are actually on par due to how much data these Llama models have been trained on. The real benefit of using these Llama models, however, has nothing to do with benchmarks, but has more to do with the fact that you can audit with 100% certainty that the model weights are not changing and that your interactions with them are kept completely private. But anyways, the growth of the Llama ecosystem in the coming years is inevitable, and long story short, the AgentOps team is ahead of the curve on this one. In this video, we are going to show how to use Llama Stack, Ollama, as well as show how to monitor Llama Stack applications using AgentOps. Keep in mind, though, that in regards to AgentOps, what you're going to see is a sneak peek of what's in the release pipeline. So keep your eyes peeled on the official AgentOps release notes for when this eventually lands. At the time of recording, this integration is being audited and tested. Here is a diagram of what we are going to set up in this video. And let's start by setting up the Ollama server. To download and install Ollama, come over to ollama.com, click the download button, and download the appropriate version for your OS. For me, this is Mac OS. From this point forward, I'm just going to show you how I did this on my Mac. So I clicked the download for Mac OS button, and it downloaded this zip file. So after you have that downloaded, you unzip the zip file and drag the resulting application into your applications folder. Then you launch the Ollama application and accept all of the permission dialogues. And then you'll be presented with this little wizard. Click next, click install. I have to put in my account password and click finish, and that's it. Then you should be able to type Ollama-V on the command line and see the Ollama client version printed out. Also note how we can start and stop Ollama via this llama icon in the menu bar. To start Ollama, you launch it just like you would launch any other application. When Ollama is running, you should see this little llama icon in your menu bar. As Ollama is a command line tool, you'll need to pop open a shell to use it. Here's an overview of some of Ollama's commands. I hope you find these intuitive. In regards to the model IDs, I personally love this table on the Ollama GitHub repo that shows some of the more used models that people like to run, along with their IDs. It's not of particular relevance to this video, but just know that the full list of models that Ollama supports stretches well into the hundreds, and even includes models from outside of Llama's ecosystem. But anyways, focus. To keep things light, we will run one of the smallest models that Ollama offers, that being Llama 3.2 1B Instruct FP16. The 3.2 tells us the family of models it was released with. The 1B tells us the amount of parameters that the model has. The Instruct tells us that the model was fine-tuned for performing instructions. And the FP16 does get a bit technical, but tells us that when the model generates text, the internal calculations are performed using numbers with up to 4 decimal places. If I'm wrong about this FP16 detail, please leave a comment. You can think of the number of parameters as a rough indication of how many simulated brain cells a model has. The more parameters or brain cells, then the smarter the model will be, assuming it's been trained on a sufficient amount of data, that is. I don't want to get bogged down in excessive detail, but what I'm trying to highlight here is that depending on training details, a smaller model can outperform a larger one in certain cases. If you're interested in learning more about how AI training works, I suggest watching this video entitled What is PyTorch, the Unofficial Movie, or researching topics like neural networks and backpropagation as a starting point. To use a particular model with Ollama, enter the Ollama run command followed by the model's ID. As a rough guideline, you'll need about 8 gigs of RAM for running models with about 7 billion parameters, about 16 gigs of RAM for running models with about 13 billion parameters, and about 32 gigs of RAM for running models with about 33 billion parameters. The model we're using in this video only has 1 billion parameters, so it should work on just about any computer. Ollama supports interactive sessions with the models you run. and also in the background serves an API. To see the logs of the Ollama API, open up a new terminal and type this command, tail-f, followed by the path to the Ollama server logs. And move this over here like this. And back in the original terminal, we can curl the Ollama API by closing this interactive session and sending curl statements like so. There are other ways to use Ollama, so feel free to experiment, but hopefully this gives you a great gist of how it works. Now that we have Ollama running, let's run a Llama Stack server. We're going to run Llama Stack using Docker, which is a tool that makes running all sorts of different types of software super easy. Fun fact, it appears that the CEO of Ollama, Jeffrey Morgan, worked as a product manager at Docker for almost 5 years. If you don't have Docker installed, come over to docker.com and download the appropriate version for your machine. For me, this is Apple Silicon. And after the download completes, open it and drag the docker.app icon into your applications folder. I've already done this, so I'll click stop, but that's it. It's that easy. In order to launch Docker, you simply open the Docker application just like you would open any other application. When Docker is running, you should see this whale icon in your top menu bar. After Docker is set up, here are the steps for how to run a Llama Stack server. First, let's create an empty folder somewhere on our computer. I'm calling mine Llama Stack AgentOps, and let's enter this folder we just created and open it with our code editor. Next, let's add a YAML file that will allow us to configure how Llama Stack works. So I'm going to create a file called run.yaml. And let's populate this run.yaml file with the following content that I adapted from the Ollama example found in Llama Stack's GitHub repo. Here is the content that we will paste into this run.yaml. And just so you can see what it looks like, here we are. Llama Stack is an SDK that provides common functionality for building agentic applications, like tool calling and memory modules, for example. Llama Stack relies on a separate service for powering the LLM. Inside of Llama Stack's GitHub repo, you'll see examples for how to plug Llama Stack into LLM endpoints powered by AWS Bedrock, Hugging Face, as well as Fireworks. But in the name of freedom, liberty, and everything America stands for, we are going to be using Ollama for powering our LLM. Okay, so here's how we do this. First, we have to make sure Ollama is running. Then we can pop open a terminal and type the Ollama ps command to see what models are being served. And we can see that no models are currently being served. And if we type this Ollama command, Ollama run followed by the model ID, we're also going to include a flag that says keep alive 60 minutes that will keep the model running for an hour after we close the interactive session that by default Ollama presents to us when we run a model. So I'm running this command. Here we see the interactive session. The model's running. And if we close the interactive session by typing Control D and type the Ollama ps command again, we can see that the model will be served for another hour. Now we can run this Docker command to run a Llama Stack server powered by this Ollama model. If you look closely at this Docker command, you'll see we're including 2 environment variables, and these are the environment variables that plug Llama Stack into Ollama. Here you can see we're telling Llama Stack to find Ollama at this URL. And And this is a little confusing, but this is how it works. The model ID that you want to use is different in Llama Stack compared to the same model's ID in Ollama. So this model, Llama 3.21b instruct FP16, has this model ID in Llama Stack. So after you run this Docker command, we should have a running Llama Stack. Okay, that looks good. And we can smoke test this by popping open a second terminal and hitting the Llama Stack API's health check endpoint. And we see the status is okay. Let's now run 2 more quick tests so you get a feel for what using Llama Stack is like. If you've done any AI agent development at all, you should find this very familiar. So first, you'll need Python installed. I'm using Python 3.13. And next up, let's create a virtual environment so that we can install packages into our project without affecting any other Python projects on our system. And if that command works, you should see a VM folder at the root of the project. Let's activate our virtual environment like so. And create a requirements.txt file. And add these packages and package versions into the requirements.txt. And then we can install these packages with the pip install command. And when the installation process has finished, let's add a file called simpleinference.py. And here is the code we'll put in this simpleinference.py file. Hopefully this should look very familiar. You can see all we're doing here is pointing this code to the Llama Stack API running on port 5001. This is the model ID we'd like to use. And this is the prompt that we're going to send via code, right? A 3-word poem about the moon. So let's run this script and see what happens. Silent lunar glow. And for this second quick example, let's show how to use Llama Stack's agent class. We're going to build an agent that has one tool. And that one tool will be the ability to use the Brave browser API. So we'll need to add a .env file to our project that will include an entry for holding our Brave browser API key. You can provision an API key on the Brave Search API console. You can sign up for here. Once you have that API key provision, copy it into your project. And in order to make these API keys available to our code, we're going to need to install python.env. And after the installation completes, let's create a file called simple agent and populate this simpleagent.py file with the following code. Here you can see we're plugging into the Llama Stack API on port 5001. Here's the model ID we're going to use. Here's where we configure the agent. And this is the prompt that we're going to send to our agent. Who won the NBA championship in 2020? Please use tools. So let's run this and see what happens. And that is the right answer. It was the Lakers. So hopefully you have a great idea or a great gist, at least, of what Llama Stack is all about. Now let's show how to set up AgentOps for monitoring applications that leverage the Llama Stack client Python SDK. First, come over to app.agentops.ai and sign up if you haven't already. There is a free tier supported. And after you're signed up, come over to the API keys section and provision an API key. And once you've done that, you can copy the API key and let's add it to our project in the .env file. Let's add a new entry that reads in all caps, AgentOps underscore API underscore key equals, and then paste in the API key that you copied. And then we add AgentOps as a dependency and run the pip install command. And after the installation is complete, we can test out AgentOps on our 2 example scripts. First, let's set up monitoring on this simple inference.py file. So let's add these packages to the top of the file. And because we now need to reference an environment variable, we have to add this command in. This is where I like to paste these commands. And then we initialize AgentOps. When you set the auto start session parameter to be false, it gives you more control of when you can track the calls. And notice how we're also going to add a custom tag. This will allow us to easily filter in the AgentOps dashboard for the calls that we're going to make with this application. So the final thing to do is wrap the code that we want to monitor, like so. And let's give it a spin and see what happens. So I'm going to clear the console. Notice how AgentOps is now printing out this link that we can command click. And you can see that we now have an overview of the call along with the specs of the environment it was ran in. And yep, this looks good. And now let's show how to monitor the other example, the one that uses Llama Stack's agent class. As we've already done the AgentOps and API key installation steps, let's go straight to the simple agent.py file and add the following code. Let's import AgentOps and initialize AgentOps after our environment variables have been loaded in. And the last thing we have to do is wrap the code that we want to track. We'll do that here. And let's clear the console and give this a spin. Okay, if we click the link that the AgentOps SDK presents to us, we're taken to an overview of this session that we had with our simple tool use agent. So yeah, hopefully that gives you a gist of how to use AgentOps for monitoring Llama Stack applications. Okay, so in this video, we learned about Ollama, Llama Stack, as well as how to monitor Llama Stack applications using AgentOps. In the link section of this description, you should see links for Ollama as well as Llama Stack. And you'll see the sign up links for AgentOps and the Brave Search API console. Plus, you'll see links for purchasing me a virtual coffee, as well as buying a yoga ball via an Amazon affiliate link. Make sure you leave a like, and subscribe, and let me know in the comments what you want to see next from the channel. And peace, health, and blessings.